After this lesson, students will be able to write function rules based on tables and real-life scenarios. Do now. Try to write a function rule for each table in the form f of x equals some number times x plus some other number. Pause the movie and resume when you're ready. For number 1, you should have found that f of x equals 6x plus 2. For example, if we input 1 here, we'd have 6 plus 2, which would give us 8. If we input 2, we'd get 12 plus 2, or 14. Input 3, you get 18 plus 2, which is 20. And input of 4 gives you 24 plus 2, or 26. So f of x equals 6x plus 2. Number 2, you should have found that f of x equals 3x. When I input 1, 3 times 1 is 3. Input a 2, you get 6. Input 3 to get 9, and input 4 to get 12. And finally, for number 3, you should get that f of x equals x minus 2. If you substitute 1 minus 2 gives negative 1, 2 minus 2 gives 0, 3 minus 2 gives 1, and 4 minus 2 gives 2. The key idea for the function rule is that this rule works for all of the ordered pairs given and all of the ordered pairs that will be on that line. Now for the do now, you may have used guess and check in order to figure out a function rule. But I'm going to show you a strategy that may be helpful to you so that you don't have to take as much time doing guess and check. It'll be a much more educated approach. So for number 1, I like to think about some of the different types of graphs that we've talked about in previous sections. So it may be a linear equation, it could be an absolute value equation, or it could be a quadratic equation. If it's linear, then it'll have a constant slope, or rate of change, where the change in the rise over the change in the run is consistent throughout the entire line. So I always start by asking myself, how do we get from 1 to negative 1, which is our rise, or change in our f of x? And then our x would be the change in the run. Well, to get from 1 to negative 1, we're subtracting 2. To get from negative 1 to negative 3, we subtract 2, and from negative 3 to negative 5, we subtract 2. Over here, we're adding 1, adding 1, and adding 1. So our rise over our run, or the change in our output over the change in our input, is negative 2 over 1, which reduces to negative 2. Now, if you recall, slope-intercept form is y equals mx plus b, where m is our slope. So what we found, the rise over run, is the slope. So far, we know that y equals negative 2x plus b, which is the y-intercept. Now all we need to figure out is the b. X and y stands for the x and y coordinates, any of the coordinates that are on that line. We're provided with 4 coordinates on the line, so we can pick any of these 4 coordinates and substitute them in for our x and our y. And again, y would be our output, just like f of x. So I could have written f of x here, which I'll actually change just so I can be consistent with what the table shows. So we'll make this f of x equals negative 2x plus b. So let's say I substitute in this 1 comma 1. So f of x is 1, negative 2 times 1 plus b. So 1 equals negative 2 plus b. Add 2 to both sides and we find that b equals 3. So now I know that f of x equals negative 2x plus 3. And I can test that out by substituting in the inputs and seeing if we get the outputs. When I substitute negative 1, negative 2 or I'm sorry, when I substitute 1, negative 2 times 1 is negative 2, plus 3 gives us 1. Substitute in a 2, negative 2 times 2 is negative 4, plus 3 is negative 1. Substitute in 3, that gives us negative 6 plus 3, which is negative 3. And when I substitute 4, I get negative 8 plus 3, or negative 5. So this rule does work for this table, and we didn't have to do guess and check. Let's try that now with number 2. So number 2, we have our rise, which is the f of x, and then the run, which would be the x. And we can see here that we are subtracting 4 each time. And over here, we're adding 1 each time. So we have negative 4 over 1, or a slope of negative 4. So we know that f of x equals negative 4x plus b. We can pick any of the points, so we'll pick, let's say, the first one again, and substitute f of x, which is negative 5 in this case, negative 4 times the x, which would be 1, plus our unknown b. Negative 5 equals negative 4 plus b, add 4 to both sides, and we get that b equals negative 1. So we found our rule. When I plug this back in over here, we get negative 4x minus 1. And now we should test that out to see if it works. When I substitute 1, we'd get negative 4 minus 1, or negative 5. Substitute 2, you have negative 8 minus 1, which is negative 9. Substitute 3, negative 12 minus 1 is negative 13. And substitute 4, negative 16 minus 1 is negative 17. Now so far, our run has been a change of 1 when we've been determining our slope. But sometimes we will actually have to reduce or divide our fraction in order to find the slope. So for example, when I take a look at this one, our rise, we're adding 2, but our slope is not 2 in this case because our run is also changing by positive 2. So our rise over our run, which tells us our slope, is 2 over 2, which reduces to 1. So we know that f of x equals 1x plus b, and now we can pick any of these ordered pairs to plug in. So 8 equals 1 times 2 plus b. 8 equals 2 plus b, so b equals 6. And then I can go ahead and plug that back in. So f of x equals 1x, or x, plus 6. And then we can check that by plugging in our domain values. 2 plus 6 gives us 8, 4 plus 6 is 10, 6 plus 6 is 12, and 8 plus 6 is 14. You try number 2 on your own, so pause the movie and resume when you're ready. For our rise, we're going up by 6, and our run is going up by 2. So our slope is 6 over 2, or 3. So we have f of x equals 3x plus our unknown b. Pick any of the points. This time I'm going to choose 0, 5 since it's usually easy to substitute in 0. So f of x is 5 when our x is 0. And I get that 5 equals 0 plus b, which means that b equals 5. When I plug that back in, we find that f of x equals 3x plus 5. And then we can check that out. Negative 2 when I substitute gives negative 6 plus 5, or negative 1. Substitute 0, you have 0 plus 5, which is 5. Substitute 2, you have 6 plus 5, or 11. And substitute 4, you have 12 plus 5, which is 17. Now don't forget that not all graphs are linear. So if I were to try to start with that approach, here I would be saying, okay, well I'd add 8. And now here I'm adding, not 8. So I can change my approach because it would have to be consistent, since the left side is going up. Well, actually, here it's going up by 2, but here it's going up by 3, and here it's going up by 3, and these two are not going up by the same amount. So I do know that it's not linear. So now I start to think about some of the other graphs that we've talked about. And it appears that this involves some sort of x squared, that it's a quadratic. Well, in fact, this one appears that f of x is simply x squared, because 1 squared is 1, 3 squared is 9, 6 squared is 36, and 9 squared is 81. So the rule for this is f of x equals x squared. Now in this case, if I were to just try squaring them, 1 squared gives us 1, not 2. So one possible option is that it would be x squared plus 1. Or it could be 2x squared, just based on our first ordered pair. Then we have to look at other ordered pairs to see which of those options works for all of them. So if I have an input of 2, if I, let's say, had guessed that f of x equaled 2x squared, when I plug in 2, 2 squared is 4 times 2 gives 8, not 5. So that one does not work. But the other option, which was f of x equals x squared plus 1, does work for our second ordered pair, because 2 squared is 4 plus 1 is 5. Now we check it for the other two just to be sure. 3 squared is 9 plus 1 gives 10, and 4 squared is 16 plus 1 is 17. So for these, use your knowledge to determine that yes, it appears quadratic, but then you may have to do a little bit of guessing and checking to see if you're multiplying by some factor or if you're just adding on some number. The journalism class makes $25 per page of advertising in the yearbook. If the class sells P pages of advertising, how much money will it earn? Write a function rule to describe this relationship. Well, if P is the number of pages of advertising and they earn $25 per page, then the total amount they earn is $25 times P, the number of pages of advertising. And we can say that f of P, since P is our input, equals 25P. The class sold 6 pages of advertising, so how much money did the class make? So now we can plug in 6 for P, and we find that f of 6 equals 150. So the class made $150. Now you try this one. Pause the movie and resume when you're ready. The choir spent $100 producing audio tapes of its last performance and will sell the tapes for $5.50 each. Write a rule to describe the choir's profit as a number of the tapes sold T. Well, we're looking for the choir's profit, which is how much money they earn after you subtract any of their expenses. They spent $100. So we can say that their profit, P of T, is equal to the money they earn, $5.50 times the number of tapes sold, minus the $100 that they spent. And so this would be our equation describing this situation.